Okay, cool. So yeah, like I said, we're going to be talking about SQL. Basically, we already got introduced to SQL back in Module 1. So you guys should at least be familiar with the idea of queries, creating data, creating tables, all that stuff. We use SQLite 3, so we'll kind of review that kind of quickly when we start up this study group. But the main thing we're going to kind of focus is saying how do we tie SQL into Pandas. And so what's kind of nice about that is that we usually do a lot of our work in Pandas, right? We like doing our analysis, we like doing all that stuff. But SQL, first of all, I mean, most companies, most places will have some kind of database that you can interact with SQL. And to be honest, sometimes SQL just is more efficient than Pandas in the way it can handle data. Sometimes you come across these things where you're like, oh, you know what? If I did a SQL query, I could do it all on the server and it can do it fine. Versus Pandas, maybe you can't load it all in memory and it just becomes more cumbersome. So that's an option too. And if you're from more of a data analyst background, or if you're working with someone who has more, that experience with SQL, it's good to be able to go back and forth. So it's just another tool for you to use. It can be a very powerful tool. To be perfectly honest, I usually see more modern data scientists, they'll tend to lean towards Pandas more than SQL, but it is something that's like, oh, it's good to have, especially because there are certain advantages. In my opinion, I do like Pandas more. When I try doing SQL, for some reason, SQL to me just feels like very long and cumbersome. Maybe it's because it's limited in number of commands you can really write down. And so that's probably why I feel that way, but it can be very efficient. I really recommend you guys kind of looking up, just Google search SQL versus Pandas and see what those differences are, because you'll see a lot of people go on either side of them. But anyway, cool. So before we start up, is there anyone, let's hear, well, I asked you guys if you guys looked at SQL and stuff. What's your comfortability with SQL? Thumbs up if you're yeah, I get all the commands. Sideways, you're kind of I probably need some more practice. Down is I don't understand SQL at all. Okay, so you see kind of sideways, thumbs up-ish, kind of thing. That's good. I think it's just kind of more practice, and the more you do SQL stuff, you just kind of get that feel of how things work. Sometimes too, you'll run across commands you're just I'm not quite sure how to do this. A lot of times just kind of walking through it, maybe looking it up, seeing what other people done. And sometimes you'll find specific things on specific databases. So for example, there's things like MySQL versus PostgreSQL versus DB2. They all have slight differences, so you have to be aware of that with the server. And yeah, you can get pretty detailed into that, but we won't get into that today. Okay, cool. So let's go ahead. Oh, hey, Jonathan. All right, so let me share my screen now and make sure I'm sharing what I want to share. Is this the right one? Yeah, okay. Sorry. It always takes me a little long time to share. Okay, so everyone can see my screen all right? Oh, you guys, it's very cool. All right, cool. And then I will share, so I made this collab notebook. So some of you guys who haven't seen this before, this is just a collab notebooks or collaboratory is from Google. It's kind of like Google Docs, but for Jupyter notebooks. So it can be really nice. It's a way you guys can all interact. So I sent out the link through the Zoom chat. If you guys want to, you guys can basically follow along a little bit. Note that I gave you editing permission. So if I'm talking about something and you start editing it, just know that it could change. But that can be good too, because later on we might talk about how to create some interesting ways to interact with classes and stuff like that with SQL. But okay, so this is just a quick review for SQLite. And we use SQLite 3, right? So the main steps you're gonna do is basically you're gonna import a library, you're gonna create a connection, right? And this is your database. Note that if your DB file, and this is just a file, I should make that clear, that holds all your information from the database. And if you don't have that database there, it will just create one for you. So note that you can create an empty database, it's just that there's nothing in it. And then this right here, I think confuses a lot of people. We usually call it the cursor. So right here, I just label it as C. This actually comes, I think, from the first lesson of section 15. So you can kind of see this very similar part, but I kind of broke it up to make it a little easier to read. But this cursor here, you can the way I kind of think about it is like it's kind of like your little messenger. It's like the person, like you have your connection, and now your cursor is basically allowing you to execute SQL commands. So I like to think of it as like, you know, your little messenger person, but they're just going along the connection. Okay, so if I run this right now, there shouldn't be any example.db in my my directory right now. So that will actually create example.db. So it's just running a little bit. It might take a second. Okay, cool. So it ran through. And then of course we can actually do executed. For example, I can create a table, and in this case, I'm creating a table called stocks, right? And you'll notice that I gave it the, I'm giving it these different variables, right? So these different columns really. Okay, so date, trans, symbol, quantity, price. And then again, this comes from the curriculum. And then we're giving it the types of data. So in this case, a date will be a text, trans probably like a transaction, you know, text, symbols text, quantity real, that makes sense. We want it to be some kind of number, a real number, and price a real number. I guess probably because you can go less than a cent. I'm not quite sure actually, but you can have the idea that you can change these how you want. So I run this now, I'll actually create a table stocks. Of course, in that table right now, there's nothing in it, right? So to insert it, values, and you'll see that I kind of space this out differently from the curriculum. In my mind, I don't know about you guys, I like spacing this out because it helps me kind of process it. You could have written this all in one line. SQL basically doesn't care about white space. It just cares about the different, what's it called? It doesn't even care about, for these commands, it doesn't even care about it being lowercase or uppercase. But you can see we're going to insert into the stocks table, and we're inserting into these values. Note that I didn't have to list all of them. In this case, I did. I could have just taken out symbol or taken out quantity and just insert those parts. So essentially those would be null values, or if the table has some kind of default value, it will replace it with that default value. And then of course I put my values right here. You can see my date, I just put a transaction, I just put buy, Google stock. I'm buying this one thing, and I just made up a number for Google stock. Okay, I run that, you'll execute, and you'll see right here, it returns, in this case, just the object of the cursor. And notice that this guy right here is the same as this one, because if you learn object-oriented programming, and we're going to get along to that today, in object-oriented programming, this is just that's basically where it resides in memory. So this is like where our object is. So you can see it's the same object since it takes up the same space. Of course, now that I executed, I haven't actually committed it to the database, right? So I can actually save my changes through the connection. Oh, which in this case, I think, no, okay, I'm sorry. Yeah, you see, this is where like, this is kind of bad form. In reality, I'd probably call this cursor. So it's a little easier to recognize like, oh, that's my cursor versus C. C could be a lot of things. C could have been connection. But anyway, I'm saving it to the connection, and then I close the connection afterwards. You didn't have to close the connection right after committing. You could do a bunch of things, then do a commit, or do multiple executions and then commit to it. So that's the idea there. Any questions on this stuff? This should not look new to anyone. Cool, thumbs up. Okay, cool. And of course, if you guys have any questions, or if you're like, wait, what did you just do? Or say, hey, I thought we could do it this way, feel free to interrupt me. Okay, so I did want to review a few different things. So I did very simple queries, for example, insert, into, create, but most of your stuff will probably be selecting data. And so when you're selecting data, this is just directly from the curriculum itself. We can see that, sorry, I'm kind of going to my thing real quick. This is, yeah, this is from the direct curriculum. So this is like our select statement. So our select statements, like select star from cats, this will get basically all the columns from the table cats, okay? Or sorry, not all the columns, but all the data from cats from all those columns. So you can see same thing here, but in this case, I have a where statement where name is a column, is equal to Maru. So basically saying I'm only getting ones that have this name Maru. If there's only one instance that has that name, Maru, then that's what I'm going to get. If there's multiple ones, I'll get multiple results. Okay, so again, should be a really quick review. Read through the curriculum, this part, if you want to review parts. But I wanted to point out a few things. So for example, order by, limit, between. These are basically parts you can add on top of your query. And this helps you get more specific. And some of these actions can be more efficient if you try doing the equivalent in Pandas, just because SQL has some efficiencies built in. And you can actually get very, very large SQL queries. I think the largest I ever wrote was something around 400 lines Of course, 400 lines of code in SQL, that depends how you write your line, but it was a pretty big table, or a pretty big query. So again, I would strongly suggest looking at these, and I don't think the curriculum even talks about all of the ones that I would think of. For example, count right here, group by. Group by is a very common one. Note that's very similar to group by for pandas, right? So we have a group by in pandas when we do a data frame. It's essentially equivalent as the one for SQL. Of course, you'll notice that it comes at the end. So the main thing I want to just point out is that there's a bunch of different, I wish I knew a better name for it. I gotta be honest, I'm not a SQL expert, but basically the different parts you can kind of chain together. And the way it usually goes is if I were to write out my SQL query, right? You have a select statement, then you have, I'll put it in this so it's easier to see. You always have your select, and then maybe some stuff right here, right? And then you have your from stuff right here. This is always true when you do a select statement. You need to say you're selecting it, and you need to say where it's coming from, okay? Basically what table it's coming from. This is where you also put joins and stuff. We talked about joins back in module 1. And then you can have other things, for example, your where statement. You could also have your group by. You can have your order by. There's even things like having. So usually having would be like right here, okay, which is similar to where, but it's within groups and stuff like that. So definitely look at different, like there are a bunch of resources online. So just a list of SQL commands or things like that. And you'd probably find a whole bunch. Okay, cool. All right, any questions about this? Pretty straightforward, I think, right? Hopefully, you, again, this should just all be review, so it's not anything big. Okay, so one thing we do start talking about is table relationships. And I think we started talking about this in, module 1, but we didn't go into the full details. And table relationships basically is a way of organizing your table. And you want to make sure that your, for example, you'll hear a lot of things called tidy data. And tidy data and normalization databases are very similar to each other. And basically it's a better way to organize. I'm not going to go through this whole thing. This is just right from the curriculum, this stuff right here. But you should definitely comb through it. But the main things I want to point out is that what are the benefits of like data normalization. So one is that you don't want duplicate data. So like if there's multiple data, like data points that are duplicates, you don't want to keep going over and over because it's going to take up space. So if you imagine if you're like every time something happens, it's going to create, what's it called? A new value, but that new value is like 50 columns long, but all of those things will be the same except for one column, then it might make sense to have a different table versus having multiple things. Now, not to say that you can't have multiple parts. So for example, if we have a list of transactions and we want to say, you know, the person who did the transaction, the date of the transaction, and, you know, like, let's say like what they bought and the price. Well, if someone comes in every day to buy something, you know, that is a legitimate thing. And it probably wouldn't make sense to make that a separate table just for that person and buying that one thing, even though it would look the same over and over and over again. Okay, but the idea here is you want to make things easier for you to later on look at. And then there's talk about, for example, like these issues that you can have, some optimizations and stuff like that. And then they talk about normal forms. One thing I would suggest is looking at tidy data. I think there was a great like little paper that's put together about how to do, how to make things well format. I like to subscribe to that kind of philosophy of data, but you obviously will have your own opinions. But I think it's a good way to approach things. But okay, so that's a different, like we call it normalizing, right? The next part I really want to mention about is something called table relationships. And you can think of this kind of like everything's related on the table. If you have just one table and another table, but they don't relate to each other, it's like, that's fine. But like the real power is when you start able to make joins and say, oh, for example, like here's a list of authors and here's a list of books, right? So then instead of keeping in your book table all the information about authors, you can keep just a table of authors and just reference. So if an author wrote multiple books, you can just reference the same author item each time. Make sense? Cool. So relationships you'll see are like one-to-one, okay, which kind of seems kind of obvious. Basically, only one person goes to one thing. So for example, this for the curriculum says employee and compensation. Each employee will only have one row in the compensation table, okay? and then one-to-many relationships. So on one-to-many relationships, we basically might have one thing go to multiple parts. So they give the example of city to zip code. So a zip code can have, I'm sorry, a city can have multiple zip codes, but each zip code is only in one city. So that's a one-to-many kind of relationship. And then a many-to-many relationships, you can think of it like, I gave an example of like, a person in buying things, a person can buy multiple things, but that same thing can be bought by multiple people. So like if you had like shampoo, and customer A, well, customer A can buy other things in shampoo, and shampoo can be bought by multiple people. So that's kind of there. And here it says sales associates and customers. So again, just know that's the basic, like these are the different relationships. And of course, I guess there's zero relationships where there's no relationship, but then I guess that's not really a relationship. Okay. Any questions on what these mean, these three parts mean? One-to-one, one-to-many, many-to-many. Okay, cool. Sounds, again, seems pretty straightforward, but it's just a way to help us organize. So when we look at this table, so you usually, as like a data scientist, you might come into another company, either working with another company or just getting data from that company. And you need to be able to navigate that data, right, on their database, because it's not yours. You might not know what everything is. So usually they have some kind of form that you can reference. So for example, this is a quick reference right here that the curriculum has, where we can see the different tables, which are all these squares, and you can see the table titles. Okay, and then the relationships are all these arrows. So you can see that, for example, orders could go to order details, shippers, customers, employees. These all have relationships to each other. And you can see here, we usually have some form of ID, customer ID, customer type ID, shipper ID. Usually those things are formatted in some way. You might also see serials and stuff like that mentioned in people's forms. But the main idea is that this way you can navigate very quickly. So I would say definitely look this over, kind of get the idea of how this would work. But usually what happens is that you see how these arrows kind of just point to it, and you kind of have to infer what's going on. For example, here has order ID, but here's order ID too. So that's probably how they're connected. But then we have product ID here. We have to go find that product ID here. It doesn't tell us about how many relationships they have to each one. So like a one-to-one, a many-to-many, or a one-to-many. So a lot of times I should say, organizations will actually create a little more detailed database structures, basically diagrams, usually called your schema. Okay. And this is usually the notation. This isn't like necessarily like standard, being like everyone does this by like there's no deviation from it. So be aware of that. But usually it means these relationships right here, one, many, one, and they say one and only one. So that means it's a one-to-one relationship. 0 to 1, I mean, that does exist. But then one, many, and 0, many. So the ones you mostly see will be one and only one, many, one or many. Sometimes you'll just see one, two. So you can see here's an example right here, and we have users, favorites, authors, books. Again, this isn't the curriculum, but I'm kind of just verbally talking about it right now. And so you can kind of see the idea here is that we have authors and books, right? And we can see this little, with a little icon right here, this little glyph of saying, okay, this is a many or one. So it's like, okay, there might be one or it could be many, right? Connecting to authors. So for example, there might be multiple books connected to just one author, right? That makes sense, okay. And of course, there's only one author for this. Like this ID of an author should only be to that one author. There shouldn't be multiple authors in this case with the same ID, right? And you can kind of see similar stuff, for example, like users. Like there's only going to be a user like with that ID, right? That's why we have this one and only one. But then going from favorites, you can see that there could be multiple favorites to, the same favorite to multiple users, right? So I might like, Catcher in the Rye, and maybe, Matt likes Catcher in the Rye, and maybe Joe likes Catcher in the Rye. So there's like 3 different people in that case who all like the same book, and that's a mini relationship. So it shouldn't be, like it takes a little bit, to be honest, sometimes it takes a little bit of work to be like, wait, what exactly is this glyph? I know it's many, but how does that relate? And you can just kind of, I like to say it verbally because it kind of helps you sort things out. But anyway, that's how you would read a schema on there.